Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we are going to be continuing on in our unit on linear and quadratic inequalities. We're doing quadratic inequalities again. This will be the last video in this lesson on section 9.3. Okay, let's go ahead and try this. This is going to be the last problem set of the day. So there's kind of two ways to do this, right? We know we have two forms that this could be in. It could be y equals a x minus p squared plus q, or it could be y equals ax squared plus bx plus c. It could be one or the other. So how do you find them? So for this one, we need to have our vertex, which is right there. And our vertex's value is -2 and 9. So that's our p and the q. So we can start by plugging that in. Y equals a x minus -2, so x plus 2 squared plus q, so plus 9. So we need this a value now, and we can see if we can do that visually. So 1 and 1, this appears normal. Let's test it with the 2 and the 4. Yeah, and then 3 and the 9. Yeah, this is a normal parabola. So it has an a value of 1. So it has an a value of 1. However, it's open down, which means it's -1. And so our final answer is going to be negative x plus 2 squared plus 9. Now we have, we're going to do general form. So when you're doing general form, you're going to use your x-intercepts, which are right here. And so we're going to start by factoring it so that we would be able to solve for the x-intercept. So this is -5, so it would be x plus 5, and this is +1, so it would be x minus 1. Okay, so we've got our x-intercepts in here. Now we have to be a little bit careful because we know that there is an a value of -1. So let's put that negative sign in there. Now we're ready to FOIL it back out to see what it would be equal to. So we have y equals negative. Let's FOIL this. So x squared minus x plus 5x minus 5. Okay, there we go. So y equals negative. This is x squared plus 4x minus 5. Now we need to distribute this negative sign. So y equals negative x squared minus 4x plus 5. All right, so now we have our two answers. We know that in vertex form, here's the graph, or the equation, and in general form, there's the equation. And they're exactly the same thing. So I already had the equation up here. It was included in the image that I covered. So negative x squared minus 4x plus 5. So that's general form, that's this one. This answer would be perfectly acceptable, right? Because they're exactly the same thing. So whichever method you like, that's the one you use. Let's give this one a shot on the right-hand side. This is a little trickier now. We're not going to use the general form here by finding x-intercepts because there are no x-intercepts. So this entire thing that we did is not going to work for this one. We kind of have to use our vertex form. So let's find our vertex. It's right there. That has a value of 1 and 2.5. All right. And let's see if we can determine our a value visually here. So we go right 1 and going up 1 is there. And this looks like it's exactly 1/2 of that. Let's see this way. So go right 2, and this should be up 4. 1, 2, 3, 4. Notice this was halfway again. So our a value is 1/2. And it's a positive value because it opens up. So visually being able to identify vertex and a value is going to help you tremendously. So now I have y equals 1/2 x minus p squared plus q. So there we go. We're in vertex form. General form, again, we can't do it with this strategy. So we're going to have to do it the old-fashioned way here. So we're going to have y equals 1/2 x minus 1 squared, but I'm actually going to square it, plus 2.5. Now I'm going to factor this. So y equals 1/2 x squared minus x, so minus 2x plus 1. plus 2.5. Okay. Now I'm going to distribute the 1/2. So y equals 1/2 x squared, 1/2 times x squared. 1/2 times -2 is minus x. 1/2 times 1 is plus 1/2. And then now I can add this in, plus 2.5. So my final answer is 1/2 x squared minus x plus 3. 1/2 plus 2.5 is 3. So here we have general form, and here we have vertex form. Now you would only have to show me one of them. I wouldn't ask you to give me both equations, but you know, now you know how to do it, just in case you were curious how to find it the other way. You just expand upon your vertex form. And so let's check the solution here. And again, these aren't the solutions, it's just the actual graph. 1/2 x squared minus x plus 3, general form. We got it. Okay, now we need to determine the actual inequality. So we have the functions, but we need the inequalities. So good points to test. I mean, you kind of figured out my plan is the 0, zeros. That's what I like to do. All right, so let's plug those in. So 0 equals, this will be 0 plus 0 plus 5. So 0 is equals 5. Okay, what is 0? 0 is less than 5. 0 is less than 5. And that statement is true, right? 0 is less than 5 is true. Why? And if you're wondering why I put the less than, it's because I was trying to make the statement true, right? I have an equation here. I have an equation here that said 0 equals 5, and that's by plugging in 0. And then now I'm trying to determine which inequality would make the statement true. 0 greater than 5, 0 greater than or equal, 0 less than, 0 less than or equal. I see it's a dashed line, so it's less than 5 would be true. And so my final answer here would be y is less than negative x squared minus 4x plus 5. This is my inequality. Okay, that's my inequality. Now for this one, I'm going to do the same thing, really. I know that my shaded region is blue, so 0, 0 should be a solution. And so I'm going to plug in 0. This is 0 minus 0 plus 3. So my two numbers are 0 and 3, and I need to put something here to make it true. Why true? Because it's in the solution region. I need to check if it's dashed or solid. It's solid. So my options are less than or equal to or greater than or equal to. And 0 is less than 3, so it's going to be less than or equal to. So this is the inequality that I'm dealing with here. And so I'm going to change it to y is less than or equal to 1/2 x squared minus x plus 3. And again, the reason for this is that when we plug in 0 and 0 back into here, you're going to get 0 is less than or equal to 3, which of course is true, which it should be because 0 was supposed to be in the solution region. So that's how you approach these. It's going to be your turn. Go ahead and try this one out. So determine the inequality that defines the solution region. So your shaded region is outside. So again, 0, 0 should be a solution. And you have these kind of points to help you out here with whatever method you prefer, quadratic or vertex form. Give it a shot and come back when you think you have the solution. Welcome back. I have the solution here for you. So I did it in both ways, just so you could check your work, whichever way that you did. So in the first way, I used the intercepts 1 and 5 to create x minus 1 and x minus 5. In the second one, I used the PQ, so the vertex, so x minus negative p, right? So then this would have to be negative 3 and 2. And you can see the a value for both of them are the same as it should be. So how did I get that a value? Well, if I start at the vertex here and I look at the scale of my graph, this is going down 1, right? And every 2 ticks is 1 because from here to here was 1. So this would be 2. Okay? So if I go left 1, I'm not going down 1. This is where it should be in a normal graph. Instead, I'm going about halfway there. And to test that theory as I go left 2, I should be going down 4. And here I go 1, 2, 3, 4. And so again, it's exactly halfway. So that leads me to the a value of 1/2. And of course, it's open down, which is -1/2. And that's going to be the same no matter what you do. Then for this one, you kind of go in reverse. So you're going to FOIL these together to get your x squared minus 6x plus 5. And then the -1/2, of course, is still there. Then you're going to distribute that -1/2. And so there I've distributed the -1/2. And that's kind of my final equation. And this one was a lot simpler, right? We were pretty much in the final equation already. So, being able to determine which one's going to be easier based off the graph you're given is definitely a skill that you should have. At this point, we want to pick something in our solution region, so that point 0, 0 works out nice. And so you just line it up. So y = 0, x = 0, and all that's left is this -5/2. So we have 0 something -5/2, and we need to make it true. It's a dashed line, so it's going to be 0 is greater than. And then you replace the equal sign in your original with the greater than, and you write it in, and there's your inequality. So both forms, here's your inequality. Testing it looks very similar for the two of them. I also just typed in my calculator the 2 just to make sure that they were exactly the same thing, and they were, right? You can see F2 is in red and F1 is in blue, and they are identical. So I just wanted, this is how I double checked that I did this process correctly. The fact that they line up perfectly means they're exactly the same. So y = 1/2, -1/2 x squared plus 3x minus 5/2 is the same as y = -1/2 times x minus 3 squared plus 2. All right, that's going to be it for the lesson. Thanks for watching. See you next time. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.